Welcome back to the discussion and thank you for always joining us. We are presenting a question that was done in K.c.s.e 2006 paper 2 question number 24, a question from application of differentiation and integration. And the question we have reads, the diagram below shows a sketch of the line y is equals to 3x and also y is equal to 4 minus x squared intersecting at points P and Q. We have been told to find the coordinates of P and Q, that is part A. To find the coordinates of point P and Q, remember the line and the curve are intersecting at points P and Q, and therefore, for us to find the coordinates of P and Q, we are going to take the line, which is 3x, and the curve, which is 4 minus x squared, and equate the two, since this is y and also this is y. We have y is equals to 3x and also y is equals to 4 minus x squared. We take 3x, which is y, we equate to the other y, which is 4 minus x squared. At this point, we can move all this to this other side such that we are going to have 3x minus 4 plus x squared being equal to 0. We reorganize the two such that we begin with the quadratic term plus 3x minus 4, and this one is going to be equal to 0. This is a quadratic equation that we are going to solve using product sum factor method. The product is going to be negative 4 and the sum is positive 3. The two factors will be equal to negative 4 and positive 1. From here, we are going to rewrite this quadratic equation. We have x squared. Instead of 3x, we use minus 4x. Now we are going to have, actually, it is not minus 4x, but this one is going to be positive 4 and a negative 1, such that if we rewrite this, we are going to have x squared plus 4x minus x minus 4, which is going to be equal to 0. From here, we know we can factorize the two in pairs. Between x squared and 4x, we have x common into x plus 4. The other pair will be x plus 4. Then negative 1 is common. So we are going to have x minus 1 and x plus 4 being equal to 0. So x minus 1 is equals to 0. X minus 1 is equals to 0, meaning the value of x is going to be 1. Also, x plus 4 is equals to 0, then x is going to be negative 4. Once we have gotten the two values of x, we can use them to get the values of y. Remember, when x is equals to positive 1, the value of y, you can either substitute it in this function here or in this line, such that y will be equal to 3 times x, and the value of x is 1, meaning y is going to be equal to 3. And when x is negative 4, then the value of y is going to be negative 12. You simply substitute it in this function here, such that we have 3 times minus 4 giving us negative 12. That means at this point now, we can give the coordinates of P as 1, 3. The reason why is that P is above the x-axis and the coordinates are positive. It means at this point here, x is going to be 1 and the value of y is going to be 3. Then we move to the coordinates of Q. Q, we are going to have -4 minus 12, and that is the answer to that particular question. So part A has already been done. We move to B, and in part B, given that Qn is perpendicular to the x-axis at n, you can see this is a perpendicular line, Qn, and it is touching the x-axis at 90 degrees. So we are supposed to find Roman 1, that is B, Roman 1, we are supposed to find the area bounded by the curve y is equals to 4 minus x squared, the x-axis, and the line Qn. So what we are going to do, we know at x-axis, the value of y is 0, and therefore we are going to take 4 minus x squared will equate to 0. If you move minus x to the other side, x squared to the other side, x squared is going to be equal to 4, meaning x is going to be equal to the square root of 4, which is going to be equal to plus or minus 2. That means the value of x can either be positive 2 or x is going to be negative 2. Remember, when we are looking for the area bounded by this curve and the x-axis and the line Qn, this is the region below the x-axis, and the region below the x-axis we are going to use the value of x to be negative 2. So the region we need, since the area is below the x-axis, we are going to get the area between x is equals to -4 and x is equals to -2, because that is what we want. At this point x is -4, and at this point x is going to be -2 here. So we are going to get the area of this unshaded part, and therefore we are going to get the area by integrating the given function, that is 4 minus x squared, then dx, between x is equals to -2 as the maximum value and the lower value as x is equals to -4. And in this case, we are going to integrate as follows. We are going to introduce x to 4, then minus x squared, we add 1 so that it becomes x cubed, then we divide by the total new power, which is 3. Then we insert the limits, -2, -4. From there now we can go ahead and substitute the maximum value of x. We are going to have 4 times x, which is -2, minus -2, we cube, we divide by 3. Then we minus, we are going to have 4 times x, which is -4. Then we minus -4 over 3. -4 over 3, then raised to the power of 3. We can proceed. So this one is going to give us -8 minus, that is plus 8 over 3, minus, we are going to have -16 plus 4 power 3 will give us -64. That is minus minus, we will have 64 over 3. And in this case, when you work out this particular question, it will be able to give us -32 over 3. which is going to give us 10 and 2/3 as the answer to this region, and the area is going to be in square units. That is simply 10 2/3 square units. That is like the area of this unshaded part, the area between the curve QN and the x-axis. We move to Roman 2. Roman 2 of this question, they need the area of the shaded region that lies below the x-axis. Area of the shaded region below the x-axis. This is very easy because we already know that NQO is a right angled triangle. We can get the area of the shaded region by taking half times, remember ON is 4 and the QN is 12, and therefore we are going to have half times base times the height, which is 12, and this one is going to give us 24. Then we are going to minus the area of the unshaded region, and the area of the unshaded region is what we have gotten as 10 and 2/3, and this one is going to give us exactly 13 and 1/3 square units. Once we have gotten that, we can now proceed to Roman 3 and get the answer to that. In Roman 3, we are supposed to find the area of the region enclosed by the curve, that is y is equals to 4 minus x squared, and the line y is equals to 3x. Already we have gotten the shaded region. At this point, the area we have here is 10. The area we have there is 10 and 2/3. What we are supposed to find is the shaded region above the x-axis. So we find the shaded area above x-axis, and the shaded region above x-axis is going to be between x is equals to -2 and 0. So we are going to take the integrated expression of the curve, that is 4x minus x cubed over 3. Then we use the limits 0, -2. Remember, if we substitute 0, we are going to get simply a 0. This is 0 minus, we have 4 times x, which is -2, minus -2 power 3 divided by 3. And this one is going to give us an overall answer of 8 plus, that is -8 plus 8/3, translating to -5 1/3. The negative sign implies that the area is below the x-axis, and therefore now to get the area we are looking for, we already gotten the area that is below the x-axis as 10, as 13. This is 13 and 1/3. We add 5 and 1/3, and this one is going to give us 18. This one is going to give us 18 and 2/3 square units. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification.